Okay, hi everyone. Welcome to track 3. My name is Jim Mckenney. As you see on the screen, I'm a practice director at NCC, and I'm going to talk about operational technology, industrial control systems, and I'm also going to pitch at the end some cyber AI stuff, which could be interesting. I've noticed a lot of the tracks are kind of going up into the time, so I think I'm going to keep mine fairly brief, maybe 30 minutes. And I would welcome interaction, so, talk about things. I think that's one of the most important parts of these types of events is to talk, right? So, might end early, talk, mill around, no pressure. Okay, so let me go ahead and get started. How do I do this? Is there a button? Just gonna do this. Okay, cool. Okay, so yes, I'm a practice director. I have a mechanical engineering degree. I also ran a bank for 10 years before that. I run a team, a global team that focuses on helping industrial facilities and technologies. The majority of my team are electrical engineers, industrial engineers. I have a few mechanical engineers, although I wish I had more. And then there's a lot of software engineers and network engineers. I also have been really pushing more toward people with controls engineering backgrounds into this, and we'll talk about that here in a little bit. Right now, the majority of my team are college educated. However, I've been noticing when we work with our clients in the manufacturing space, especially, there's a lot of talent from vocational schools and kids who come out of high school and don't go to college with a fundamental grasp on just using their hands, putting things together, problem solving, following the rules, documenting things like this. So it's very interesting to kind of see how this is evolving, where maybe the idea of having a PhD or something to move something from A to B is not necessarily needed. We do a lot in the different sectors. You can kind of see them on there. Pharmaceutical, transportation, mining, oil and gas, do a bunch with electricity here, which I'll talk about here in a little bit. Anyway, it's very interesting. I work all over the world. I'm going back to Netherlands next month, working with them, and it's very interesting to listen to concepts they have about what safety and security is and the world. Okay, so what are we going to talk about today? OT in our daily lives. I guess you call it the cyber frontier, evolving landscape. Career pathways is really important, and then a conclusion Q&A. First, real quick, so how many people in here, and just feel free to raise your hand or whatever. I can't really move, sorry. Yeah, I can't really do that though because I have coffee. It's okay. Priorities, right? They refilled the caffeinated one, by the way, so I have caffeine. So how many people are vendors? You sell stuff? How many people? Vendors? You have vendor? Any vendors in here? Integrators? No integrators? Vendors? Okay. How many people have a security role? Okay. Oh, wow. Okay. Any kind of operators? Oh, nice, operators. Okay, cool. Okay. How many people work in oil and gas? Nobody. Okay. Electricity, manufacturing. Manufacturing, nice. Transportation? Okay, cool. All right. This is going to be kind of interesting, right? All right, so, okay, so, this is I heard there were high school students and stuff around, so I was hoping a few would be in here, but if this is remedial, I apologize. But it is what it is. Okay, operational technology. Most of us probably work with IT based on our hands being raised. There's a few of us who work with what we call operational technology. There's a big difference, I think, from a functional side. But we also see a convergence of the technologies about what does it do is more important than what it is to a certain degree. A lot of industries out there are clean water, requires operational technology. Turning a light switch on, operational technology, the cars we drive, oil rigs, maritime. I work a ton with cruise ships. Boy, that's one big city of operational technology, automation, propulsion, navigation, your toilets, important stuff, right? Railroads, worked on the railroad for a good 10 years, worked on safety control systems, positive train control, all high technology. At the end of the day, controls engineers, boots on the ground are what's important. It's operator. It's all about a person operating technology. And a lot of things that we look at is like, when does technology replace a person? And when can't it? And so operational technology, when you start thinking about this, there's different priorities. And so this is the biggest difference that I see when we approach kind of like the ideal client persona kind of thing, because I'm a practice leader, so we have to drive business and do things for people. We used to approach CISOs and IT directors. And we had the same old story where the whole CIA triad, right? Doesn't really work in these fields. It doesn't work in those industries. Why? What's the most important thing? Reliability. It's all about reliability. And safety. It has to be about safety. And so that world that we're in the operational technology world, talks about physical processes like valves and actuators, thermals, regulators. It's not about a 0 and a 1 when it comes to a dollar sign and a bank account, right? And so ruggedized things. We have to think about the environment. We have to think about pressures on the environment, high temperature, low temperature, extreme conditions. It's not sitting in a data center, it's in the field. And when does it fail? So failure modes and effect analysis, all these fun kind of formal disciplines we go through on the engineering side start to really apply and start to dictate how we work with technology that used to be considered IT, but now functionally it's considered kind of OT. And so we can go on and on about this all day long about what the difference between OT and IT is, and at the end of the day, it's really hard if I look at a device to tell you if it's OT or IT, but I can tell you what the function is. If I go to a factory, every device in that factory run by a good controls engineer, he can tell me or she can tell me exactly what it does and why it's there and how to fix it and when it's going to break. If I go into a data center, I look at a box, I have no idea what that stuff does, right? So it's very interesting to kind of watch these worlds collide and diverge. On the right side, you kind of have a decision tree that we use. I can't really read it, sorry, but you can kind of see how can you tell if it's IT, OT? So there's these formal things we can go through to kind of help describe what OT is. But it's really simple at the end of the day. Okay, so I have a couple examples of OT. Work with lights out facilities. So no humans, fully automated. It's really hard to do, by the way. It's probably not going to be. Elon tried to do it, right? A couple years ago, it didn't work out very well. He kind of revisited that whole thing. That's a common theme that we see, right? Operational technology needs an operator at the end of the day, right? So assembly lines, we do work with a lot of robots. Lots of robots now are based on COTS. You got Windows, IoT stuff. That's just Windows, by the way. So don't get distracted. Welding, painting, part installations, everything's programmable at this point. We call it mutable now. In the old days, engineering would be immutable. Now it's mutable. And so we used to think about materials, about what a material does and its attributes. And typically, material doesn't change. It changes over time, does certain things. Software is not like that anymore. Software does anything and everything. It's a pattern, right? So it's a lot different now when we look at an assembly line where we can program things and we can flip the switch, so to speak, and instead of generating a 1/4-inch plywood, we can generate a 1/2-inch plywood, right? Or 3/4 with the switch. We used to have to retool these things, right? And so it's very interesting to kind of watch what's going on. And this is a good example of a car manufacturing. Another one is smart grid. So smart grid is really the fun stuff. We can talk a long time about, anybody work with renewables, like wind, solar, bio, anything like this? Anybody work with power plants? Coal fire, liquid, thermals, hydro? Okay. So anyway, you should probably think about this. If we have time afterwards, I'll come back to it. But OT is like controlling all this stuff. And high technology, the things in Silicon Valley that have been disrupting like your payment processing, right, and your mobile apps or your phone for your banks, they're doing the same thing for electricity. And it's distributed now. So we call it DER. You can look it up. CISA and like DHS has a bunch of stuff on DER about some of the vulnerabilities and threat landscapes that are evolving as we start integrating small form factor kind of wind farms and things like this into our extremely monolithic power generation and transmission infrastructure. Big issues with this. So smart grid technology is interesting where we got sensors and things and meters at everybody's houses now, and they all kind of control the flow and like they report these things. Once again, it's technology IT that's going into your house, but at the end of the day, it's doing an OT function, reliability, efficiency become super important. We start plugging in all these interestingly developed devices that are small, compact, and have lots of interesting code. We need to remember that reliability, efficiency, #1 things when it comes to this. And so it's kind of interesting to watch from smart grid technology. Electricity. Okay, so let's talk a bit about OT in our daily lives. Electricity, we all love our electricity. Generation, we work with thermal plants. So thermals are just burning things. So it'd be like coal or liquid natural gas, kind of the primary ones in the United States. Goes in a boiler to steam, drives turbine. Work with like Mark 6, like Google GE Mark 6, really cool stuff. Work with those and some other ones, like the Siemens have some big ones. They're just giant turbines, which is really kind of cool. All these things are controlled by operational technology, and at the end of the day, they're actually really simple devices. When you generate the electricity, you have to transmit it. So once again, it's the high voltage power lines. You see these transformers and things everywhere. They get stepped down and brought up, and you got detecting faults. You got linemen going out fixing these whole things. Another whole operational technology thing. So the cascade from like generation, transmission, and distribution are typically your electrical co-ops run by just your local kind of cooperative kind of stuff. I think Iowa has like 5 or 6 cooperatives out here. They kind of like manage distribution of the energy into your rural communities. Lines go down, they dispatch the linemen, right? The whole kind of thing. Once again, like monitoring consumption patterns, ensuring the areas with the higher demand receive power supply, so the whole balancing authorities and stuff start coming into play. At the end of the day, this is a very complex system that's supposed to be resilient, and has been kind of demonstrated resilient. The thing that brings it all together with all these different pieces is SCADA. So that's supervisory control and data acquisition integration. So this is like a short term for all the technology that we put together. And so this is the orchestrator of everything, right? So we do tons of stuff with SCADA. SCADA is kind of over on top of DC and OT kind of stuff, ICS, industrial control system. So this is kind of the big thing on top that someone looks at, kind of orchestrates everything. This stuff, SCADA stuff, tends to be commoditized now. So you're going to see a lot of like IoT kind of devices out that are really kind of SCADA, and they're replacing things like HMIs and things like this, which I'll talk about in a minute. Key takeaway on this: you want your power, operational technology. It's really important. Okay, how do I do this? Okay. There we go. Oh. Did I do this? Okay. Did I do this one already? Oh, yeah. Okay, so I talked about this already. So that traditional power, generate power in a coal fire plant, monolithic, gets distributed out. It's different. DER is different. And the idea is we all should be thinking about this. And like if we have high school students, probably even kids in elementary school, think about this as an interesting career path. If children or you're interested in green energy and kind of saving the planet, or whatever your political structure is, we all think electricity is important. And so the whole idea, like if you're interested in like your kids or the high schools or the college, they're interested in like green energy and renewable and things like this, distributed energy resources is the thing to think about, okay? And the idea is that you used to have this monolithic, there's about 2,300 power plants in the United States or some such, right? And there's more, but whatever. And they're all kind of very monolithic. They're all just kind of generating their own power at any given time. They're kind of orchestrated by a central system, which is a balancing authority. So it says, hey, I need more power over here. It needs to go over here, so you need to up your output, right? And they have plans and things like this. If you work in the industry, you know it's kind of interesting. But when we start integrating in green energy or like solar or wind, now I have it's no longer monolithic, right? Now you have a whole bunch of smaller systems that are going to get tied in to the same quote unquote grid as that power plant. So 3 megawatts, whatever it is. Now you got a bunch of solar plants all around Iowa, for example, that are just tied in. And it may not seem like it makes a difference, but as you start to assert more and more of the energy coming from these other sources, it's no longer 95% that's generated by thermals anymore. It could be 80% or 75%. The problem you run into is like when the sun doesn't shine, what happens? Right? You don't get electricity. When the wind doesn't blow, there's no electricity. And are you storing this energy anywhere? Probably not so much. Although they're kind of doing that co-ops, it's kind of interesting. But so now there's this whole idea of balancing what's going in and out, and you have all these inputs from all these different independent kind of farms. Think of those independent farms that are attached, and generator can contribute. And you always have to maintain the same voltage. You have to maintain the right work plan, the workloads, and things like this. And so it becomes this really complicated equation, a lot of really difficult calculus. And so the technologies, the reason I do this is because the technologies that do this, they're all becoming automated. And so we need to think about these things as we have all these new endpoints, risks, threats, vulnerabilities, all these endpoints coming into a traditionally isolated and kind of monolithic system. And we all seen that happen with online banking, with the advent of what? Internet banking. Used to be monolithic, now it's everybody. And then it's mobile banking. Then what happens? Just think of the same thing, with this whole industry. And so once again, IT, OT, IT's kind of cool. I think OT is kind of, if we can get more people involved with the OT stuff, get their hands dirty, so to speak, it's going to do a lot for the future. Let's see, next. Okay, so careers, and I know this is kind of an older crowd, but think about this for people, other people, younger people. It could be older people, I don't care. Controls engineers. Does anybody know anybody who are controls engineers? No controls engineers. We need controls engineers. Come on, people. Like, really. Manufacturing, plants, food and agriculture, energy. Railroad. Anybody work in the railroad? Nobody in the railroad. Okay. 1.5% of our GDP is freight, right there. Train doesn't move, what happens? You don't get fresh food. In New York, you don't cross Mississippi, don't get fresh food. Coal doesn't get delivered to the coal-fired plants. They don't have enough on hand more than a week. I mean, it just goes downhill really fast. So these things, and I worked at the railroad for 10 years, it was really hard to hire people, really difficult to hire people to make $80,000 a year with a high school education. Really difficult, and this was like 5 or 6 years ago. Really difficult. And we hired a bunch of IT people to do signals, and they had no idea what was going on, right? And the trains would stop moving. So you had to bring the older people back in who actually knew what was going on, right? So these are really important industries that are operationally focused, and we don't sit in the room anymore. We have to go out into the field, interact with people. Operational technology is about people, processes, and then technology. And then high manufacturing, I even hate to mention this because most of the kids I work with, they really want like the lights out and the semiconductors and like, yeah, that's really nice, but honestly, like the whole idea of like 4.0 is like way out there. This other stuff is gonna be important forever until we don't need electricity or water anymore. So lots of opportunities for people. And it's not necessarily the traditional path of going to college and getting a software engineering degree. Not that there's anything wrong with that. It's a different career path. Okay, so the future. I think we all really, if we're in cybersecurity, the things that we do, regardless of our industry, impact other industries like upstream, downstream. There are some skills if we work with people or just very interested in like security, and especially if we're like a provider, managed services, do testing and things like this, incident response, forensics. The thing that when we start, and there is a dearth, I would say, in this OT industry of qualified people helping this industry like energy and manufacturing and ships and things like this. Like there's a lot of OT people with traditional IT security mindsets and skills coming in, and it's at odds. And what happens is it's really good work from the IT perspective, but the values and the objectives and the outcome doesn't necessarily line up with the expectations of a plant manager who's responsible for that plant running, right? Or the plan of the power plant to continue to make the right amount of energy and distributing it. And so it tends to sow distrust, and it's like, why are you here? What are you doing? What's an intrusion test? Why do you want to break my stuff? And this is what we've been hearing forever. But when you start thinking about physical processes and like the impacts downstream, it's like it's more than just a 1 and a 0 and a bank account number or whatever it may be, or your phone's not working. It's actual legit like stuff, right? And so I encourage everyone, if you're interested in these types of industries, like read up on RAMs. Like as an industrial engineer, did a lot with RAMs. Reliability, availability, maintainability, and safety is a whole discipline. It's rather quite interesting. So my team, like we do RAMs assisted pen testing or intrusion testing. And there's like whole methodologies and things like this we've developed to go through these things. But the idea is that we do formal processes to do testing versus just kind of ad hoc, can we break something? And so there's a formal process we can go through in our fields to test out these systems, whether or not it's like an electric automobile or a train or a turbine or something. And that tends to build a lot of trust and be much more effective than just kind of releasing the hound, so to speak, to break something. So anyway, RAMs is really cool. Also, managed services, analysts, and technology integration. This technology is very kind of foreign to others, and at the end of the day, though, it's a function, not necessarily a form. Form's going to come in COTS nowadays. A PLC would cost you 20, 30 grand. In the old days, now Silicon Valley's got one you can buy for $1,000. It's it's a FCA. It's nothing much. It's just commodity hardware. Hell, you can have a Raspberry Pi do stuff now. I mean, it's not that big a deal. Does the same thing a $30,000 PLC does. But what does it do? Is it ruggedized? Is it safety, integrity, rated? Like all these things that go in the background to develop that. It's the difference. Like you can't just copy code anymore. Which is like where the software's gone. You just copy stuff. Anyway, so managed services, like people who can integrate with this OT. So testing and validation. Yeah, there's tons of web applications out there. So like traditional software engineers and stuff we really need those. One of the things that we work a lot with is SBOMs. Anybody do SBOMs? Yeah, nice. Wave of the future. I'm telling you. I told you this 5 years ago. SBOMs. This is when I worked in the railroad. We had a map of every single asset in the entire railroad, and we had literally millions of assets over half the United States. You knew everything down to within like 3 inches, right? And we surveyed each one of those. Can you tell me what all your assets are at your bank? Like what does it do? Why is it there? All the stuff in your data center, and in your office. Like what does all that stuff do, right? Software bill of materials is that bill of materials. It's like, what does this do? Where is it? How does it interact? It's your inventory of everything you have. And the first discipline we have in engineering is you have to know what you have. If you don't know what you have, that's your first problem. So asset management is number one. And we do this in security. I think visibility or asset is like one of the first things, right? SBOM, workload composition analysis, WCA is our whole thing. By the way, this is contrary to like what Microsoft does and others that just develop tons of code and they copy it and copy it and copy it and copy it and copy it, and you take 5% of that and use it, and 95% isn't used. And so WCA gets rid of that bloat. You know, you start to figure out what you need, what you don't need, lower your exposure, your service, attack surface, right? You start lowering it by getting rid of the code. No, fix vulnerabilities, get rid of the code. And so, yeah, stop that. Incident response, totally, this is like big stuff. I've got a really good, for example, I might have a really good IT incident response team who can respond to, bank. I love banks. But can they go out to a wood products manufacturing facility? Can they go out? Can they go out to, can they put on the safety gear and go out there and interact with the controls engineers? Making lumber, or, right? Can they do that? So there's this whole thing of OT and IT and trying to get the whole world working together. We could talk all day long on the threats that are coming along lines. We do lots of threat modeling and do research and things like this about critical infrastructure. You probably heard this in the news all the time. Threats are evolving and hitting the more OT stuff, trying to disrupt physical processes. Power grid is obviously on the list, way up here. IT and OT, IT-assisted OT, or adjacent technologies to OT, influeing what data acquisition, sensors and things like that. It's all IT, which is IT. The idea of the quality of the data coming in and OT just making typical decisions becomes an issue. So incident response is like super forensics, another big one. When you hear about all the derailments in the railroad, how much was that a physical issue and how much was it a software issue? I don't know, do you know? Like, what capabilities do we have to do forensics on that? What capabilities do we have with, and I'm not railing on rail, I just worked in rail, so I understand. What's the typical thing we go to do? Are we asking other questions? Was there a coding error? I remember back with like the 787 or like with the Southwest, the airflight, it's like code, right? Okay, key tools. Okay, live ranges. A lot of companies are coming online with live ranges. Really fun stuff. This is one of the most difficult things to do, is have all the different systems, be able to build it and maintain it, have like live ranges. Extremely complex, extremely difficult to do. Lots of companies are building these things. One of the most important things is to get the IT stuff and the OT stuff in the same field, in the same range. Hopefully that's not mine, sorry. Okay, so live ranges are really cool. Blending them together. Typically, Active Directory is going to link all those together, regardless of what they say. Missions, so we do a lot with missions. Missions are cool, missions for IT, OT, and hybrid environments. So missions are like, we want to take down this system, or maybe change the power output to this from this, right? Or turn off the valve control, overflow control on a basin to make it overflow, or change the chemical composition of the water purification system, right? And that's a mission. It has a direct impact. It's not just, I got root. I don't care if you got root. I can tell you 90% of the time when teams go in and get root on an OT system, it means nothing. It means absolutely nothing. There's usually a big red button that someone's pressing, or an operator or someone watching this stuff. You have to do a lot more than get root, right? And so missions talk about this. So live rangers are cool. You can find root, and you can always root a system. Not always, but sometimes. Missions are really cool because it's goal-oriented. It's outcome-oriented. It's like, this is the actual adverse effects that would be meaningful to me or the person needing electricity, right? Formal curriculums are cool. We see a lot more formal curriculums coming out, and I'm working on that. NICE and MITRE have some really cool things come out. MITRE came out with another OT, an ICS one, which is kind of cool for a framework. So you can look that one up. It's kind of neat. Red teams and blue teams, do a lot with red and blue teams. We really need defense with these things. So not just traditional IT, but OT defensive teams who understand the impact of physical interaction with the real world. Right, this servo does this. One of the really cool frameworks that, wow, this is like one of the best things I've seen, is 62443. Anybody work with 62443? Oh man, really. So big in Europe. Blueprints. Anybody work with Older models, like Purdue model. Is Purdue dead? Is the Purdue model dead? Yeah, I do wish it was. The Purdue model has caused so many issues as people try to create smart factories or bidirectional communications, and like Purdue doesn't support that very well. So IEC 62443 is more of a campus, like a zero trust model, but it goes way beyond that. It's not just a way of examining or organizing what your assets are, where they sit. It's more way back to the beginning, like how do you develop these things, right? How do you manage your suppliers that have this widget that want to be plugged into your factory at this plant doing this specific thing? So it goes way beyond just like what this is and where it should touch and where it should sit in your factory. So this whole thing, this will affect building automation, any kind of smart infrastructure to your cities, transit authorities, airports, cruise ships, everything. This is like one of the things that we see as like really, really important. Yeah. It is very expensive. If you want to get your master cert, you can go through SANS. It is expensive. It is one of the few things, in my personal opinion, that's worth it. How much have you seen it for? Is it 12 for all 4? Plus the tests? Wow, that's not that bad. I mean, yeah, 12, we should talk afterwards. But yeah, that's one semester at college. Yeah, I mean, it is one of those things, and you're going to see this kind of spinning out, like, if you worked in UK, the NCSC, like, there's CIS over there. They're requiring people who work on critical infrastructure in United Kingdom for NIS2, to have 62443 or a series of other accreditations. And that goes into effect in June of next year. And like, if you provide services for them and you not have these things, you can no longer bid, period. I was talking with the gent here earlier. Sorry, go ahead.
Oh, I was going to say, for SANS, they want to try to reduce the price. They want to try to reduce the price. There was like a volunteer per conference review. You get like 70% off.
Well, is that how you got? Is that why it's only 12 grand? Because you got 70% off? Oh, nice. Yeah. Yeah. Do you only work in the U.S.? Okay. Yeah, but you're one of the operators. You're an operator. You're like, yeah. Yeah. Wow. Yeah. There's also a lot of grants coming around, especially for the energy sector. Well, a lot in the co-op space. There's a lot of money coming down for education from the state as well for this stuff. Okay. So how am I doing on time? Oh, okay, good. Okay. Any other questions? I want to talk about anything before I get into the cyber AI stuff? I mean, go ahead. Yeah, go for it.
In your field in OT, what sort of communications protocol do you use for connecting all the sensors to, operating equipment and stuff like that?
Yeah, so that depends. When I talk with people, like they have a really good understanding of TCP/IP. There's like Modbus and there's other things going on with Profibus. There's a whole bunch of unique kind of vendor-developed kind of proprietary protocols. The other day, they all go over IP. That's 90. The things you're going to worry about. Let me put that. From an architecture perspective, one level up, I wish I had a diagram up there. But you're not worried about the serial things going out to your actuators and stuff like that. You're worried about more communications, like your RTBs and stuff like this. Those are the things that are all basically this IPs, TCP/IP. And a lot of the tools that we're going to see, anybody use cool tools like Dragos? Use Dragos? Yeah, Dragos is awesome. Anybody need other cool tools? Cisco's got a good one, right? Dragos has got one. Anybody else? There's like so I say the 80-20 rule, if you want to get into space, just be a good network engineer. I mean, I say that about any IT or OT. You got to be a good network engineer. Like, it's totally important. Everything else is kind of like the controls engineers. Honestly, worry about that stuff. Everything will come.
So Four Scouts not really?
Boy Scout, really?
Four
You like Boy Scout?
Yes. Son of it. And
Yeah, let's talk about it. What's that called?
That.
Boy Scout, what's that?
Boy Scout. What's Boy Scout?
It's a Fortinet product.
It's a what?
Fortinet product. They do firewalls, switches, and Four Scout is a passive network switching. It interfaces with a lot of tools, just like those.
Yeah. Yeah. So okay. So who here? Okay. So this is fun, right? So anybody run vulnerability scanners on our networks? Whoa! Active or passive? Raise your hand if active. Active. Passive. Only. And then passive only. Passive only. Passive only. Okay.
This is our kernel kind of
It depends on
stuff.
the network.
Here's
There's
the
data
network.
networks. There's
Yeah.
passive.
Yeah. Yeah. This is the biggest thing. Like our red teams. It's like okay. First off, we're just talking now, so whatever. Like we go to my teams and like the software engineers, network engineers come in. Like some of the best, like the smartest people are like, you know, these typical kind of hacker people. But they don't communicate well. They don't follow directions. They don't document very well. So it's like herding cats, right? But one of the interesting things is when you're looking at a skill set, when you're trying to find someone to move into the space, is if they're really good black team, like a red team, like if they're zero, like they're really good at stealth attacks. Zero noise. Like that's the whole approach. Someone running a vulnerability scan or a port scan like falls over something. It'll make the system fall over 99% of the time. Depending on your architecture. Let's just say it'll make it fall over. Reasonable chance. But someone who's really good at stealth attacks, not allowed to run a port scan. Not allowed to run a vulnerability scan. Not allowed to actively fingerprint a system. Not allowed to try to log in. Right? What do you do? How do you approach the system? What's that?
Low and slow. He's a low and
Low and slow. Low and slow, yeah.
Use a different means. You don't use the traditional means.
Yes. Yeah. And so the mindset of a very well adapted that kind of person who is evading, the whole idea is like stealth. That is the kind of people who tend to work really well in this environment. Right? And so what we'll do is we'll go in, we'll set up like a counter environment where we'll put like a Dragos platform and a Clarity or there's only in, and that's actually basically the taps in it. It basically takes all the taps and just builds an asset inventory, builds a vulnerability inventory, and a threat inventory. The most important thing is the asset inventory, right? That's the most important thing. Not even necessarily vulnerabilities. And so passively with taps, you can actually build an entire map of your entire infrastructure with zero scans. Like no vulnerability scans. And it's actually, they're actuals. We call it the difference between actuals and as is. Or not the difference. The actuals are the as is. People give us network diagrams and block diagrams. They make absolutely no sense. Like, well, ahead of time, they'll give us block diagrams and say, this is the way our plant's laid out. I'm like, are you sure? Are you sure? And a lot of times the sponsor is from the corporate people, not necessarily the plant manager or the ops people, right? So we go out to the plant, it's like, this is nothing to do with what this picture is, right? The problem we run into is like the assumptions that we use when we build our test plan are based on paper, not on the as is. Right? So a lot of times we'll go in ahead of time and we'll say we're required to have a tap, we're going to put in the zoning in. We're just going to do a sample of your network in 2 weeks to build up an entire inventory of the as is. Not what you think is there. Right? And then from there we have more of a control over, we understand what this is, what it is, where it is, how it interacts, and we can sit down with the controls engineer and say, what is this thing? Why does it have 4 NICs in it? Why does it have 4 NICs in it? Right? And those are the conversations which are incredibly important to have. And I guarantee you there's a really good reason that's 4 NICs. Right? There's a really good reason. And attacking the person because it has this extra NIC in it is not a good idea. Because there's a reason why it's there. So you want your widget made? There's a 4th NIC. Right? So there's a lot of different techniques that you can walk through and approaches. There's formal testing programs. There's things like just assisting people so that they can be stealth, but also putting in a kind of more And sorry, I didn't mean to go off on that whole protocol thing, but does that resonate with anybody? Does that make sense? Or do we want to push back? Push back. Anybody love kind of like you like the Nessus? Does everybody use Nessus though?
We did it in D&D.
Yeah.
It's a tool.
It's a tool.
I have many rusty tools.
We got many rest. Is it a fit for purpose tool? Is the first thing I do. Is it fit for purpose? You gotta evaluate. Is it fit for my purpose? Okay, so let me talk a little bit about this. So this part's really cool. So, anybody heard of the AI Cyber Challenge? Okay. When you get homework assignment, look this up. This conference is about AI. This is what's going on. This will immediately affect us within 6 months. And I'm telling you, we see lots of I've done DARPA challenges in the past, and this one is the one. Like, this will immediately impact our future. We have 2 years. It's a 2-year challenge. The idea is that you can build an AI-powered way to protect your critical infrastructure, protect your widget factory, protect your electricity distribution. And this is a really difficult equation. And so basically you have, okay, so I'm building a team. We got a team, which is kind of cool. There's other people building teams. There's 7 of them that have funding from DARPA. We may or may not get funding. I don't know if we will or not. But anyway, so we've done things like this in the past, and I have an engineering company which this is going under that NCC. Our team is called OTF. Anybody know what OTF is? OTF, on the field. It's a military field. For the next 2 years. So we're doing a think tank model. All members of skills and Davenport. So we got scientists, we got LLM learners, leaders, we got high school students coming in, we got a vocational school that's being attached to this. Going up to Canada, I'm going to speak with them. One of their schools up there, and like they just do a bunch of controls entry. We want to get like, you talk about variety of inputs and things like this. Sitting in a tower, ivory tower somewhere is not going to get this. OT experts, controls industrial, automation techs, all these things. We're going to bring these people together and do this really cool thing. This is like one of the most difficult problems we'll ever try to solve. And AI just may be able to do this. Anybody work with CAS? Complex adaptive systems? Okay. That's one of the, you can Google CAS, or we can talk about it afterwards. Self-built materials, we talk about that, workload compositionality, vulnerability identification, threat modeling, hunting, and forensics are kind of key capabilities and blend together in order to make this work. This might not necessarily be about patching a system. Does patching work? Does patching work? Raise your hands if you think patching works.
It works better than if you don't.
Okay. Is patching prevention? No, not really. Yeah, we all need a patch, right? What if you had a system you didn't patch? Didn't have to patch. We call that a hardened system, right? Anyway, so you have to blend all these things together. It's gonna be, this is a really cool thing. And like I would, this cyber challenge I think is gonna be one of the coolest things ever. Forensics, threat modeling, hunting, vulnerability identification. We've got like vendors like, I'm not gonna drop names, but like Dragos. We're gonna partner up with them and others in order to build out tool sets. At the end of the day, this will be open source though. Is it 11? Okay, sorry. Okay, now this is a really cool thing. Who here is a coder? Anyone? Okay, code. Okay. Do you ever use one-time codes? Pardon? Do you ever use a one-time code? Like spontaneously generated code? Okay. Anyway, a lot of the industrial equipment we see out there, where did I write up? Oh yeah, they have like known vulnerabilities, like all the stuff that goes out is known. They got Java, right? You got all these things. Interesting thing is like when we're in a factory or something and we see like a PLC, like a Rockwell XXX, that we call like a Rockwell, or a Siemens XYZ, it's the same code. It's the same build, right? So the idea is like you build a virus or malware, you attack one PLC, it's got a common set of vulnerabilities, you can just infect all of them, right? This is why copying code is not just So this is really interesting. So this is a big issue because we're not allowed to patch things in factories. We're not. In medical devices, even worse because we're not allowed to patch medical devices, right? Except FDA requires, right? So you can't even you know so you can't fix it. And so quote unquote fix it. So the idea here is like this is really interesting where you can actually have like a whole factory in a box. Like what if I had like a I hate to say Windows embedded device. This is called a Windows embedded device. And it just had a set of equipment like the 5 standard things I need in a factory, like actuator, temperature monitor, just whatever it may be, sensors. Instead of having a set piece of code like a PLC, like ladder logic that I have to code, what if I just told AI, this thing needs to do this? I have 4 pieces of equipment in order to heat this water. And you have 3 devices. Now AI, generate the code for that. And it's one-time code. It's not based on a pattern that someone developed at Microsoft or whatever for X amount of dollars. It's just generated on the fly. That is, by definition, immutable. This is so odd because in the factory it's immutable. We're not allowed to change things. What if we change the equation where we're always just changing it? Like it's always random. It's always random. It's very interesting to think about what you could do potentially with AI, not from an adversarial perspective, but more of a on-demand, fit-for-purpose type of devices using generic stuff. And so this idea is like there would be no HMIs anymore. No more HMIs. I want to change from 1/4 inch to 1/2 inch to 5/8 inch plywood. I don't need an HMI anymore. I just tell the AI to generate the code on those 4 devices to make a 1/2 inch versus 3/8. Right? No more interfaces for someone to interact. Plus, it's local. I'm not going up to the cloud anymore. There's no more external inputs. So very interesting stuff. So this is one of the fun things, like when you start thinking about AI applications, and like I think this is really cool, is like you can start thinking outside of things, outside the box. But it really is kind of. But it's not just mass production of COTS and saying I'm going to use an IoT Microsoft embedded system in order to transfer my code on top of it and do the same thing. And by the way, I'm going to inherit all the vulnerabilities and issues Microsoft ever had. Right? So very interesting stuff. If you have high school students or something like that, you can LinkedIn on that whole thing. So does that sound interesting to people? Like, do you think like cool AI stuff? Does that sound cool? I mean, it's still really exciting. Anybody work with large language models? A little bit. Yeah. Like one of the first things my team did was one of the agent-based models. We run the agent ones, like Baby. Anybody run Baby? No. Auto. Yeah, Auto. You run Auto? Load it on Kali. Load it on Kali. See what happens. Yeah, very interesting. Yeah, I mean, you don't have to know how Showdown works. You don't. Like you have to have the API key. And you don't have to that, right? You don't have to know any of these things. Like literally, you don't have to know any of it to dig up Showdown. And so all of a sudden you have this massive library of industrial vulnerabilities on the internet, and you don't even know how Showdown works. You just need an API key and like a credit card, basically. Right? So think of all the tools that people already load up on Kali. And all I did was load Baby on it, or Auto on it. And it's, by the way, it's local too. Make an independent local. Now touch that to the dark web. Put Tor on it. And watch it kind of go crazy. And then like you have like these nice models that have don't have the ethics on it, right? They haven't been trained to be nice. So you don't have to break it. And so yeah, that's the scary part of this whole thing of like, you think script kiddies are crazy? No, I mean don't be worried about people just loading stuff up on Kali and just letting it run in your environment. But this is kind of the opposite of it, right? There are good things and bad things that can happen. And so this is the starting part. We'll be building up red and blue teams and live fire courses in order to test this out and things like this and running missions and we'll automate we call them pods. It's like dolphin pods, right, of AIs, right? And so we'll have pods that are competing with each other. It'd be really cool. So anyway, I think that's what I had.